Hello and welcome to the lecture about Prim's algorithm. Prim's algorithm is a greedy algorithm that finds a minimum spanning tree where the total weight of all edges in the tree is minimized. There are conditions corresponding to the original graph. The first one is that the graph must be connected, undirected, and weighted. Additionally, parallel edges and self-loops are not allowed. There are also some conditions related to the minimum spanning tree. There must be no cycle in the minimum spanning tree. In addition, the minimum spanning tree must also contain all vertices. So, let's dive into an example. Suppose we are given this graph. In the first step, we initialize the minimum spanning tree with an arbitrary vertex. Here I will choose node E randomly. In the next step, add the next vertex with the minimum possible edge connected to node E. There are 3 nodes connected to node E with 3 edges. However, the edge with the least weight value is the one between node C and node E. In the next step, find the minimum edge among all edges connected to node E and node C. There are 3 possible nodes and 4 edges. The minimum possible edge is between node E and node D with a weight value of 3. Repeat the previous steps, but be careful not to form a cycle in each step. You can assume that we treat node E, node C, and node D as a single node, and we must add the minimum edge that remains. Now there are 3 possible edges. As you probably noticed, adding the edge between node C and node D forms a cycle, which is not allowed. Choose the edge between node E and node A, which has the lower weight value. Finally, the last vertex will be added using the minimum possible edge. The last minimum weight value is between node A and node B with a value of 2. Adding more edges would form a cycle, so stop here. The minimum spanning tree is now complete. You may have noticed that a special case can occur when there is more than one edge with the same weight value. Suppose the weight between node D and node C is 3, just the same as between node E and node D. In such cases, you can pick either the edge between node E and node D, or between node D and node C randomly and move on as long as no cycle is formed. I hope you enjoyed this video and thank you for watching. Feel free to subscribe if you found it helpful.